In this video, we will learn how to evaluate expressions. So when we're evaluating an expression, we're basically given values for specific variables or letters, and then we're replacing those letters with those values in solving. So with this evaluating expressions lesson, to be honest, it's a really great review for order of operations and for integers, adding, subtracting, multiplying, and dividing. And we're just adding like a new step to it by replacing the variables with numbers instead of just being given the problem. So this is a guarantee question on the GED test. It's also a huge topic on entrance exams such as the AccuPlacer. So here, if we're given values for A, where A is 8, B is -6, D is 3, X is -4, and Y is a half or 0.5, we want to evaluate the following expressions down here below. So one thing I always recommend for students to do is when you're replacing the variable with a number, I always encourage students to put that number in parentheses. And I'll really share why as we continue through the video. But you'll notice like sometimes I do and sometimes I don't. But I would say 90% of the time I always put parentheses around the number I'm replacing. Excuse me, the variable I'm replacing with the number. The first question, I have a squared plus 3d squared. So for my a, I'm going to replace a with 8. So I'm going to place my 8 in parentheses, like so, plus 3, because that's just part of the problem there above. And I'm going to put my d value in parentheses. My d value is 3, and I square it. So like I said, this is great practice for order of operations. So here we have parentheses are involved, but there's nothing to solve within the parentheses, right? This is just a 3, and this is just an 8. So in this case, parentheses just really helps us know what number we're squaring, right? So if there's no parentheses in the sense that we don't have anything to simplify within the parentheses, I want to square these values. So 8 squared is 64 plus 3. I'm going to put a dot now for times, and 3 squared is 9. So I have 64 plus 3 times 9. So order of operations, I definitely want to multiply before I add. So I'm just going to write this up here. So I have 64 plus 27. And that will give me a value of 91. Okay, so again, like I mentioned, it's really good review for order of operations. I strongly encourage you to check your answer in a calculator, but I don't encourage just typing it in the calculator. That's not good practice to make sure you're really understanding what you're doing, but it's great practice to check it at the end, because then you're doing it yourself by hand, right? And then you're also practicing on the calculator. When you do enter it in the calculator to check, I always encourage students to enter the original, right? We want to enter the original question here in your expression, I should say, in your calculator. We don't want to do like this step or this step because we could have made errors within there. So if you're using your calculator to check, always check the original. Next, we have x times y minus 2, and the y minus 2 is in parentheses. So let's just replace our x of -4, parenthesis, my y value is 0.5 or a half, minus 2. Okay. So we have to follow the order of operations and perform parentheses first. So we have a half minus 2. Right? So if you think of halves, how many halves are in 2 would be 4, right? So if I have 50 cents and I take away $2, right, I'm in the hole, and I'm in the hole 1.5. And I want to times that by -4. So here's our review of integers, really, right? I have a -4 times -1.5. So a negative times a negative is a positive. Now I have 4 1.5. So you could think of that like 4 stacks of $1.50, right? Or $1.50 4 times. So $1.50 and $1.50 is 3, and then double that again would be 6. So this would evaluate out to 6. Next, we have fractions involved. Let's just keep our composure here. I have a half times y plus 1/10 squared. So my y value is a half, so I'm just going to rewrite it to start. So I'm just going to bring down my half, replace this, replace my y with a half, plus 0.1 squared. So order of operation tells me I have to evaluate my parentheses first. So I have a half times 0.6 squared. It's going to rewrite up here. So I have multiplication and exponents. I want to do my exponents first. So let's do this by hand. Let's keep our composure here and multiply decimals just for a little bit of a review. 0.6 squared is the same thing as timesing it by itself. 6 times 6 is 36. Here, 3. 6 times 0 is 0, plus 3 is 3. And I have 2 decimal places here, right? I have one spot here and one here. So my answer has to have 2 decimal places. So I go back 2. Right? So 0.6 squared is 0.36. So I have half times 0.36. Now, when you're taking half of something, it's kind of nice that it's a very compatible fraction. I'm just taking half of 36 hundredths. So really, you could just figure out what half of 36 is, and that's 18. And then it's in hundredths, right? So this would be 0.18. If these are making decent sense, that's awesome, because the lessons in IXL, in my opinion, are even easier. As you continue to get into your 90s and 100s for your SMART score, they get more challenging. But I do know that fractions and decimals, I think, are only present on one IXL lesson. So if these are making okay sense, you're in great shape. Next, I have a negative x minus d. So my x is -4 and my d is 3. So I can't forget the negative that's already here, right? This negative is already here. But now my x value is -4. So I'm going to just kind of make it like this. Hopefully we can kind of see the difference there. So just to really emphasize here, that negative is this one, right? And my value for x is -4. So we're not losing any negative signs there. Then I just have my minus, and then my d value will go right here, which, let's see what the d value is, 3. Okay, so if you guys remember from our integers unit, if you have a minus a -4, whenever you see a minus a negative right here, you can just change that to a plus. So this is a +4 minus 3, and 4 minus 3 equals 1. So that evaluates to 1. One more question on this page. So I have d minus x minus b. So d I know is 3, so I'm just going to record that. 3 minus, my x value is -4, minus, now b, I don't know if we've used b yet. B is -6. So within my parentheses here, I have -4 minus a -6. Remember from past videos, I can add the opposite here and do -4 plus 6. So now I have 3 minus a -4 plus 6 is 2. So this also evaluates to 1, like the last question. The next video, I'm just going through more examples of how to evaluate expressions.